All right, so if we're looking at number 3 here, okay, I've got a carbon hydrogen containing compound reacting with oxygens making CO2 and water. What kind of reaction is that? That is definitely a combustion reaction. Whoop. Small letters, please. Combustion. Okay, so if we're writing that out, again, I don't know what the prefix for 14 is. Okay, you could write fuel. This stuff is actually called hexane. Okay, it's reacting with oxygen. Okay, and it is producing carbon dioxide and water. Okay, special balancing rules for combustion reactions. Do I need them both? 6 is an even number, so I need to start with a 2 and then balance alphabetically. All right, so starting with carbons, 2 times 6 is how many? 12. All right, so 12 needs to go here. Okay, 2 times 14 is 28. Okay, 14 times 2 is 28. I got 28 hydrogens on both sides now, and now I can total up my oxygens. 12 times 2 is 24 oxygens in the carbon dioxide. Okay, plus 14 times 1 is 14. Okay, that should give me a total of 38 oxygens in the products. So I need 38 oxygens in the reactants. 19 times 2 is 38. Okay, everybody with me there? All right. Can we do number 4? How many people are done 4? Okay, let's look at 4, and then I'll give you some time on 5. Okay, so on number 4, I've got chlorine, just the element, plus lithium, just the element, gives me lithium chloride. Now, why did I write it lithium, then chlorine, when lithium came second on the reactant side?
Lithium's the metal.
Lithium's the metal. Now, I don't have a lot of tricks in my bag of tricks, but when we get to predicting the products of a reaction, I will definitely do something like that, and I will catch probably a quarter of you on that one, okay? Because we naturally go to the order it was given to us in, and we just write it in that order. And a lot of people will write ClLi, okay? Just because that was the order it was there, forgetting, you know full well that a metal comes first in an ionic compound, but we just forget because we're moving along on something. Okay, so something to watch for. Okay, lithium chloride. Okay, what kind of reaction is that? Somebody whispered. Say it louder. Synthesis, yeah, definitely. Okay, 2 elements combining to form a single compound. Right now, this one I can use the balancing rule for the other 4 types. Biggest number. Biggest number is 2. Okay, I only have 1 chlorine here, so I need to put a 2 in front of lithium chloride, but in doing that, I also get 2 lithiums, so there need to be 2 lithiums over there. All right, I'll give you a couple more minutes on number 5, then we'll go through that one, and then we're going to look at what happens when we go the other way, and we're given the word equation, and we have to meet the formula equation instead. Okay, on number 5, okay, we've got magnesium fluoride. Okay, and we've got cobalt 2, or actually cobalt 3 nitrate. Okay, remember it's important to have those Roman numerals in there. Okay, and that is going to make magnesium nitrate on the other side. And I don't remember if I told you guys this or not, but if I figure out it's cobalt 3 in the reactants, it is also cobalt 3 in the products. It's not going to change from 3 to 2 or 2 to 3 as a result of a chemical reaction. That part of it you cannot change. Okay, so we will be looking at cobalt 3 fluoride. Okay. What kind of reaction is that since they're all ionic compounds? Double replacement. Okay, what should I balance first? What's my biggest number? 3. Okay, so does it matter whether I do nitrate or fluorine first? Doesn't make any difference. They're both a 1. So let's start with the nitrate just because that 3 is first. There's 3 nitrates here, but there's only 2 on that side. What's the lowest common multiple of 2 and 3? 6. Okay, so if I multiply this side by 2, I get 6. If I multiply this side by 3, I get 6. But putting those 2 numbers in affects the cobalt and the magnesium. So I'm going to fix the cobalt right now. There's 2 on this side. How many over here? Just 1. So what needs to go here? Okay. When I do that, does that mess up my fluorines? Okay, it gives me 6 there. So how do I get 6 here? Put a 3 there. Does that fix my magnesium? Yep, it does because I put a 3 there already. Okay, pretty typical double replacement kind of reaction. Okay, questions on this type? Okay, so the next type we're going over is the opposite. I give you the word equation and you have to now make the formula equation, still identifying type and balancing. These are more detail oriented, so you have to watch out for more things, like you have to drop and swap in the ionic compounds. You've got to watch out for all those special elements that come as 2s or 4s or 8s on the periodic table, okay? Because you're only going to get the words. You're not going to get the formulas. You're going to have to make those. So they're not any harder. You just have to watch out for more things. Okay, so let's do number 6 here as an example. Okay, so on number 6, I've got copper 2 nitrate reacts with magnesium to form magnesium nitrate and copper metal. Okay, so first compound is copper 2 nitrate. So that's an ionic compound. I go Cu. The Roman numeral tells me it's the 2+ kind. Okay, and it's with nitrate, NO3. Okay, and that's a -1. So then I'll drop and swap. I'll need a 2 here, and I'll need brackets around that. Okay, and it's going to react with magnesium. Doesn't say magnesium's with anything, it's just magnesium. Okay, and it says then it's going to form magnesium nitrate, so Mg 2+ with nitrate 1-. Okay, drop and swap. There's going to be a 2 there, and again the need for brackets and copper metal. Okay, now what kind of reaction is that? It's a single replacement reaction. I have an element reacting with an ionic compound, and I'm getting a new ionic compound in a different element. Okay, so definitely a single replacement reaction. But was there a lot more stuff for me to do there? Right? It's way easier to write out the names because you already have all the numbers. Here's where that becomes challenging. If I don't get these numbers right, like if I don't drop and swap this compound correctly, am I going to balance the equation correctly? Okay, so now suddenly a 3-mark question because of 1 drop and swap error, the best mark you can hope to get is 1 out of 3. And that's if you identify the reaction type correctly. Okay, but if you don't get the formulas, if you don't get the reaction written out correctly, you won't get it balanced correctly either. I mean, you might make your reaction balanced, but it's not the right reaction, and thus it's also not balanced correctly. Okay? All right, so now we got a balance. I think we're good. What do you think? Okay, there's 1 copper, 2 nitrates, 2 nitrates, 1 magnesium, 1 magnesium. Looks good to me. Okay, everything should be a 1 on that. Okay, does that make sense? Fundamentally, it's not any different than what we were doing before. You're still being asked to balance a reaction. Okay, you know how to write formulas. That's not a new skill. You're just using it in a different context. Okay, and then still identifying those reaction types that we've been doing already. Okay, try 7 to 10 there. Give you a few minutes to get ahead of it. I didn't write the name for that. I gave you the formula, okay, for a dodecane. Okay, that's what it's called. So we'll just write C12H26, and it's reacting with oxygen gas. Got to remember that that's O2. It's one of our special elements. Okay, and that is going to produce carbon dioxide and water. Okay, what kind of reaction is that? It's a combustion reaction. Okay. Okay, so you get 1 mark for that. You get 1 mark for having the reaction written correctly. Now we got to balance it. Do I need both special rules? 12's an even number. Okay, I'm going to add some really big numbers here. Okay, so for carbon, balancing now in alphabetical order. 2 times 12 is 24 carbons. Okay, 2 times 26 is 52 hydrogens. So I need a 26 there. And now I can total up all of my oxygens here. So I'm going to have 48 oxygens, 24 times 2, okay? And I'm going to have another 26 on top of that, so 74? Yeah, 74, okay, divided by 2 should be 37. If my mental math is right, you can check me, but I think that's right. Okay, questions on that one? I wouldn't give you one that big on a quiz or a test. Okay. How many people have done number 8? Okay, let's have a look at 8 as well then. Okay, so number 8, I've got lithium nitride. Okay, lithium is a metal, so this is an ionic compound, +1. It's with nitrogen, that's a -3. Drop and swap. I've got Li3N, and it breaks down. Decomposition reactions are ones you always have to watch for the production of special elements. Okay, it's going to break down into nitrogen and lithium, or either one of those special elements. Which one? Nitrogen comes as a 2. Okay, if I forget that, I'm not going to get the balancing right. Okay, little details, a lot of details when we're doing this. Okay, so now I need to balance all of this. Biggest number is 3, but I know right off the bat that if I just transfer the 3 over there, I'm going to be erasing it right away. How do I know that? Because the nitrogen's not balanced either, and it's a 2. Okay, so I can do that. Again, that works most of the time, the biggest number, but occasionally, okay, I go like this and go, ah, crap, that didn't work. Okay, and then I got to erase it and start with the next thing in line, nitrogen. There's 2 on the products, so I need to put a 2 here. And when I do that, it gives me 6 lithiums. So I would have that instead. Okay. All right. Thank you guys to try 9 and 10. Give you a couple more minutes, and then we'll go through those. All right, so for number 9, we got hydrogen sulfide. So hydrogen listed first means it's behaving as a metal. It is with sulfur, which is a -2. So we're looking at H2S for that stuff. Okay, and it reacts with calcium hydroxide. Calcium's a 2+. Hydroxide's a polyatomic ion with a charge of -1. Drop and swap. We're going to have a 2 outside the brackets for that. And that is going to produce calcium sulfide. Ca, 2+, sulfide, 2-. Okay, those are good. And water. Now, how should I write water in this one? Should I write it as H2O or HOH? HOH. Okay, if you're making water and you've got hydroxide and hydrogen that are separate in the reactants, it's way easier to track where everything goes by writing water like it's an ionic compound. Obviously it's not, but we can write it that way and make it easier for us to track everything when we're balancing. Okay, all right, so if we're looking at what kind of reaction type this is. Everything's ionic, so this would be, nope, close. Double replacement. Yeah, this is double because everything's ionic, right? If all the compounds are ionic, then it's double. If there's one ionic in an element, then it's single. Okay, so we got double replacement reaction here. We got biggest number being 2. It's on both hydrogen and hydroxide. They have the same charge. And they end up together over there. Okay, so now my hydrogens and my hydroxides are balanced with that one move. Okay, there's one sulfur, one calcium, one calcium. Looks like everything else is balanced. Okay, making sense? These take a little more practice than the other ones. Okay, not gonna lie, there's just more to do here, but fundamentally they're the same. Okay, now number 10 is one to really drive home the point of special elements. Phosphorus. Is phosphorus one of our special elements? What does it come as? 4. Okay, and it reacts with oxygen. Is that also a special element? Comes as a 2. Okay, and that is going to make triphosphorus, P3, dioxide, O2. What kind of reaction is that? That's a synthesis reaction, right? 2 elements combining to form a single compound. Okay, start with the biggest number. Biggest number is 4. All right, I've got 4 phosphorus over here, and I've got 3 over here. What's the lowest common multiple of 4 and 3? 12. So basically I'm multiplying by the opposite, right? Here I'll multiply by 3, and here I'll multiply by 4. Now my phosphorus are balanced. But in putting that 4 there, I now make how many oxygen? 8. What goes here? A 4. And we're done. Okay? So, as I said, we're going to be working on this the remainder of the week and next week. If it's, proven difficult today, that's okay. It usually does. Okay? But the more we practice it, the better and faster at it we'll get. Okay, yesterday I handed out to you guys the worksheets. I know a few people started working on it, which was not my intention, but they did. Okay, so your worksheet has these problems on it. Okay, I would like you to do just the first 5 of this type. Okay, so just these 5. Okay, I gave you this yesterday, right? Yeah, okay. So 1, 2, 3, 4, 5. Don't go past that. When you get to 5, just stop. Okay? Because we're going to flip to the other type, do 5 of those. All right? So that's the first time. Okay, so on our first one here, okay, we've got just iron, right? That's the elemental form of iron, and it's reacting with hydrogen chloride, and that is going to make iron 2 chloride. Okay, now how did I know it was iron 2 chloride? Well, chlorine's in group 17 where everything has a -1 charge. There are 2 chlorines, so there's 2 negatives. So I have to get 2 positives from the iron, so it's iron 2. Would you get that wrong if you didn't have the Roman numeral?
Yes.
Yeah, you would. Okay, got to have that Roman numeral there. Okay, plus hydrogen. All right, so that would be our reaction in words for 1 mark. What kind of reaction is that? Single replacement, right? We have an element reacting with an ionic compound. So that would be a single replacement reaction. And if I want to balance it, hydrogen and chlorine, which both have charges of 1, are 2's in this equation, so it doesn't matter which one I start with. I'll balance the chlorines and the hydrogens at the same time with that number, okay? And everything else should be a 1. Okay. Yeah. Any questions on number 1? And for number 2, Na is sodium, that's its elemental form, plus chlorine, also in its elemental form, and that is going to make sodium chloride. What kind of reaction is that? Synthesis, yeah. They don't get much easier than that one. Okay, now I have to balance it. Biggest number is 2. Chlorine's here, 2 chlorines there, gives me 2 sodiums, 2 sodiums there, 1 in front of the chlorine. How many people have done 3? Okay, let's look at 3 as well then. Okay, so number 3, I got water. And it just appears to be breaking down into hydrogen gas and oxygen gas. Okay. Biggest number is 2. It's on pretty much everything. But oxygen has the biggest charge. So I'll balance it first. Okay, I'm taking this 2 and I'm balancing it there. When I do that, it gives me 4 hydrogens. Now I have 4 hydrogens there and a 1. Okay, what kind of reaction is that? Decomposition. Okay, I'll give you a couple more minutes on 4 and 5 and then we'll do those and then we'll look at some that go the other way. So on number 5, we've got calcium by itself, oxygen by itself, and they are combining to form an ionic compound, calcium oxide. Okay, what kind of reaction is that? Synthesis. Okay, I got to balance it. Biggest number is 2, and it's only on oxygen, so a 2 there balances the oxygen. A 2 there fixes the calcium.
2, 1, 2 for number 4.
Okay, and then for number 5, okay, we've got aluminum. They like synthesis reactions in this one, it would appear. Okay, aluminum plus oxygen, okay, is going to give aluminum oxide. Okay, so this is as I said, a synthesis reaction. And now we got to balance this. Biggest number is 3. Okay, so and over here it's a 2. Lowest common multiple is 6, so a 3 there and a 2 there balance the oxygens, but that gives me 4 aluminums, so 4, 3, 2 should be our balancing numbers for that. Okay, questions on any of those? Then I would like you guys to, I think you're on the next page here. Okay, 1 through 5 there, these go the other way. So I'm giving you the word equation, so I want it written in formula form. I want the type, I want the formula form equation balanced. Okay. All right, so on number 1 we have magnesium. Okay, so just Mg, that's how it comes as an element. And it's with chlorine. What do I have to remember about chlorine? Yeah, it's a 2. It's part of the 7 in the 7 over there, okay, on the periodic table. So it's a Cl2, okay, and that is going to make the balancing a lot easier because this is a 2 plus, this is a 1 minus, and when I drop and swap, I have 1 magnesium and 2 chlorine, which is exactly the same thing I have on the reactant side. And that, what kind of reaction? Synthesis reaction is already balanced. Okay, so that little detail, right? Checking for those special elements. Okay, we've actually done this one already. Dihydrogen monoxide. That's the, okay, gives off hydrogen gas. What do I have to remember about hydrogen? Comes as a 2. Oxygen as well. Okay, so we've seen this, like I said, we've seen this one before. Okay, we got a 2 there, so I got to put a 2 there to balance my oxygens. 2 times 2 is 4, 2 times 2 is 4. Now it's balanced. What kind of reaction is it? Decomposition. Okay, give you a few more minutes on 3, 4, and 5 there. If you're finding there's not a lot of room on that page for you to write, that was my intention. I had every intention of having you write it on a different piece of paper. I was trying to save trees. See, I passed the guilt on to you by using your paper as opposed to mine. Okay, are we ready to go over number 3? Okay. So for number 3, we got aluminum. Okay, aluminum's not special. It's reacting with oxygen, O2. Okay, and it is producing aluminum oxide. Okay, so when I have aluminum, it's a 3 plus, oxygen is a 2 minus. Okay, now what do I have to do with that? Take the 2 here, put the 3 there. Okay, what kind of reaction? Synthesis. Okay, now I got a balance. Okay, biggest number is 3, so lowest common multiple of 2 and 3 is 6. 3 here, 2 here, 4 there. Okay, how many people have done 4? Okay, all right. Phosphorus, is it special? How special? Right. Okay, and it's reacting with oxygen, O2. And that is going to produce phosphorus pentaoxide, so PO5. Biggest number is obviously the 5, but if I try to balance the oxygen first, this isn't going to work out, is it? I'm still going to have to balance the phosphorus first. So I'm going to put a 4 there. Now my phosphorus are balanced. 4 times 5, okay, is 20. So I need a 10 here and a 1 there. Okay, how many people have done number 5? Okay. All right, so on number 5, we got nitrogen trihydride. Okay, reacts with oxygen, special element, okay, and produces nitrogen and dihydrogen monoxide, or water. This one you can't type. Why? It looks like a single replacement, but why isn't it? Because nitrogen trihydride is molecular. Yeah, this is not one of our basic 5 reaction types. If you put single replacement, that was probably the best match that you were aware of, okay? But in fact, this is not a single replacement reaction because nitrogen trihydride is not an ionic compound. So a bit of a tricky one there, okay? No way for you to get the typing right on that one. Okay, we gotta balance this thing. Biggest number is for the hydrogen. Okay, I got 3 here and I got 2 there. Lowest common multiple is 6. 2 times 3, okay? 3 times 2. Do I have a problem? I'm not gonna make my oxygen balance here, am I? Okay, so let's start again. Let's balance the nitrogen first instead, see if that works. Okay, nope, that's not gonna work either. Okay, I'm gonna have the same problem if I do that. So I'm gonna balance the oxygen and see if I can get that to work. Okay, so if I put a 2 here, nope, also not gonna work. Okay, so let's try, this is a tricky one for balancing. Okay, let's do the hydrogen first. We started it out, I made it 6. Okay, I put a 2 here, but that didn't work. I'm gonna just double it. I'm gonna make it a 4 instead and just see if I can make that work out. Okay, so now I've got 12 hydrogens. I'm gonna put a 6 there. I like how this is working for my oxygens now because I can make them work. And I can just put a 2 here to balance my nitrogens. That's about as tricky as a balance gets because we didn't get it the first time. Didn't get it the second time. Third time, meh. Okay, but by the 4th time, we kind of figured it out. Sometimes they go like that. And occasionally, I will throw you a tricky one. All right, I would like you guys to go back to that first set, okay, and try 6 to 10. But first, I'm gonna, oh no, it's 9:46. Let's just try 6 to 10 here. I think you guys will get through those pretty quick. Okay. All right, so for number 6 here, we've got bromine. Okay, that's its elemental form. And we've got sodium chloride. Okay, and that is going to give us sodium bromide. And chlorine. What kind of reaction is that? Single replacement reaction. Yep. Okay, so we got single replacement. Now we got to balance this thing. 2's the biggest number. It's on 2 things that both have a -1 charge. So a 2 there and a 2 there should fix both the chlorine and the bromine and keep the sodium as a 2. All right, and then for number 7, okay, I've got copper. Do I need to put a Roman numeral on it here? Here, when it's by itself? No, it doesn't have a charge yet, right? It isn't a charged particle until it's in a compound. So this is just copper. Okay, I'm just bringing that up because I sometimes see that as a mistake. Is reacting with sodium chloride. Okay, gives copper. Now I put a Roman numeral on it. 2 chloride. Okay, and again, I figured that out by going, this is a -1. There are 2 of them. Okay, so I have to get 2 positives from that 1 copper, and it is going to give us sodium. Okay, what kind of reaction is that? Single replacement. Okay, and to balance it, okay, just the chlorines out of balance to start. So if I put a 2 here, I balance the chlorines, but then I have to put a 2 here to balance the sodiums. There's 1 copper on each side. So we're good to there. Okay. How many people have done 8? Is 8 a tricky balance? A little bit, right? Okay. Let's have a look at number 8, and then I'm going to talk to you a little bit about the labs here. Okay. So first one here, this is a molecular compound. Okay. Sulfur dioxide reacting with more oxygen to give us sulfur trioxide. Okay, now in balancing this thing, here's the trick with this. Oxygen's in every part of it, but what I'm really concerned with is balancing the reactants with the products. Okay, so if I'm looking at this, I can see I have 4 oxygens on this side, 3 on that side. What's the lowest common multiple? 12. Okay, so I'm going to do this. I might have to change it, but I'm going to start this way. I'm going to put a 4 there. When I put a 4 there, I also have to put a 4 there. Okay, so now I have my sulfurs balanced. Okay, I've got 12 oxygens, I've got 8 here. Okay, I put a 2 there. It's balanced, but is it correct? No. What do I have to do with all of those numbers? 4, 2, and 4 can be reduced. Yeah, and you have to do that. Sometimes that happens. When you first get something going, okay, you have to take it down, okay, if you happen to get double or triple, okay, the number, just because that's the way you balance it. If you notice that, you have to bring it down to its lowest terms. Okay, in talking about the lab reports that were due this morning, okay, just a couple of things. They were like generally pretty good. I do have a suggestion for next time. We are going to be doing a lab on Monday, okay, on chemical reactions. When you're putting the lab report together, please listen to the recording that I make of the pre-lab. Okay? A lot of people miss marks in like the hypothesis and then the variables and stuff like that, but it was stuff I basically gave away in class, okay, and was recorded in the recording. So always a good idea to listen to the recordings that I put up. Okay, and guys, here's what I mean by that. Don't go do the whole report, then listen to the recording, because that takes twice as long. Okay? While you're doing the report, listen to the recording of that part. Okay? Pause it, make whatever you have to do. Okay? Listen to the next part, do whatever you have to do. Okay? But I did notice that some people really lost marks, and I know, because I went back and listened, okay, that was actually stated explicitly in the recording. Always a good idea to use that resource. Okay? All right, tomorrow we'll go over the labs, okay, because they'll be handed back to you probably by end of day, okay, and we'll go over those in class tomorrow, okay, so you can kind of see where you got your marks, where you didn't, okay, have the opportunity to ask questions, and then we'll keep going on reaction steps.